So you know there's a lot of coordination worldwide. And when we get talking ultimately about our weather forecasts, a lot of it is actually done by computers, but the computers need to be fed what the conditions of the atmosphere are, what we call initial atmospheric conditions. And then they basically, via type of weather forecasting generally called numerical forecasting, they take all of this atmospheric conditions and spit out a forecast using different models. But we'll get to that. So actually the forecast then, as it turns out, you might imagine, is only as good basically as the stuff that goes into the computers. So how are we going to get this initial conditions? Well, like the slide says, we can get them from the land, we can get them from the sea. That can be on ships or these little buoys that kind of float in the oceans. We can get them from weather satellites. I think this is kind of funny. We can equip commercial airplanes that are flying anyway. I wonder if they get extra pay. I don't know. But we can equip them with atmospheric measuring devices and send that information so we can use it. We talked about weather balloons earlier in this course. I just think weather balloons are so cool. They go up twice a day and they carry these little boxes. And this is April 2012, and just this month I read a little, I think it was a Twitter thing, that talked about folks in Alaska are actually trying to find these little, these little boxes from weather balloons. I have a slide here in a minute kind of reminding you about weather balloons. But anyway, so yeah, we need a bunch of data to feed our computers to spit out a numerical forecast. Now there's other ways of kind of nuances of that sort of forecasting, but we'll get to that. So of the land sites, about 10% of them, about 1,000, they're land sites here in the United States, and the majority of those land sites are run by the FAA, the airport people. Isn't that interesting? I think it is. So we're going to see here in a minute a set of little instruments collectively called these ASOSs, and things that they can measure kind of automatically is surface temperatures, humidity, pressures, cloud cover, wind direction, speed, visibility, fog, and precipitation. So this is kind of a typical collection of devices known as an ASOS, Automated Surface Observing System. And yeah, they are mostly run by the associated with the airports. So the weather balloons, I mentioned that in Alaska that they are now going out and collecting these little boxes because they are reusable if you can find them. So there's a slight difference in the boxes that are sent up with these as part of carried by these weather balloons: radio sound and a Raw sound. And I think a good way to think of it is the Raw sound gives a little bit extra information with regard to wind, both wind speed and wind direction. We talked about, in this unit of material, we also covered hurricanes. And remember, hurricanes, you do drop wind sounds into the hurricane to get a sense for what the wind speed and direction is doing. So, weather satellites. It's another way to go ahead and get the atmospheric conditions. Now, weather satellites would be an example of an indirect measurement versus a direct measurement. But there's two types of weather satellites, and they vary both in how far above the Earth's surface they are. One's a little bit farther out there. And then they also vary how they orbit the Earth. So, for instance, we have the polar orbit satellites, and they orbit the Earth from pole to pole. And this is kind of neat. So they're checking out Santa Claus. That's not the neat part. But how long does it take them to complete one orbit? About an hour and a half. Isn't that crazy? That is going pretty darn fast. And these polar Earth satellites are the closest of the two types of satellites. And when I say closest, I mean they're the closest to the Earth's surface. So these polar orbit satellites are great for looking at the poles. But picture this, as they orbit, the Earth is spinning on its axis, so it's kind of a hit and miss with regard to kind of the middle latitudes, with where the Earth will be as it spins. So it's kind of hit and miss. Now, if you're wanting to get the middle latitudes, the equator and that sort of thing, you're probably going to want to use information from a geostationary satellite. Now, geostationary satellites are further out. They are further out from the Earth's surface. And they kind of, well, let me say this part. Geostationary satellites are stationary with regard to as the Earth rotates on its axis, these hover, they're stationary over a particular location. So basically then these satellites need to kind of keep up for the rotation of the Earth. Okay? And as it turns out, they are generally, and you're going to see a picture here in a minute, they generally kind of orbit in the vicinity of the equator. So they're a little bit further out though. So this is the polar orbit satellites. Picture that. Okay. And this would be what the orbit of a geostationary satellite. Okay. Now, so here in North America, we have what we call a goes east and a goes west. And these are the stationary, geostationary satellites that are focusing on our east coast and our west coast to kind of give us real live information. So when the satellites get their information, basically what they do is take a scan, and they scan it at different wavelengths, but they complete one composite scan about every 15 to 30 minutes, and then they update it. On the internet, if you're interested in looking at our goes east and our goes west data, you can get pretty darn up-to-date data that is streaming, I guess, from, I don't know directly, but from those satellites. Right? So I mentioned they're taken at a variety of wavelengths, and in general we can think of them as basically three wavelengths, three types of scans that these satellites take in order to give meteorologists some good information. One is they're scanning for light in the visible region of the electromagnetic spectrum, and that basically tells you cloud cover. Oh, before I go on to the next one, in order to get a visible light back, though, how do I say this? That side of the Earth needs to be in the daytime. Infrared images can actually be taken during the day or the night, and what infrared is doing in that part of the region of the electromagnetic spectrum is it is getting temperature information. And I know when we talked about severe weather, I said that one of the things that they look for is with a developing storm is if the cloud tops are really cold, that means that chunk of air has risen very high. So infrared images. And then the last one is and I believe this is also in the infrared region of the electromagnetic spectrum, but they can massage and pick the right wavelength to actually look for water vapor, water in its gaseous state. Now that's kind of a cool thing, because if you know where the water gas is, the water vapor is, that can kind of give you some hints, obviously, for where large amounts of water vapor, potentially you could have condensation. So this is just kind of a snapshot. These are pictures from your textbook. This is a GOES satellite image of our GOES, looking at visible light, so that would be cloud cover. This is looking at infrared, so that would be looking at thermal imagery. And you can, boy, it's hard to miss this right here, isn't it? Okay, so that red would be cold cloud tops, very unstable right there. And then this is the kind of wispy looking thing. It's not clouds, it's actually giving you an image, and the white means there's more there, giving you an image of water vapor, water in its gaseous state. So check this out. The part that I want to go ahead and circle its counterpart here. So here it is in the infrared, and here it is in the. So if you've ever heard a picture is worth 1,000 words, then that's kind of an understatement. If we take all those kind of current conditions and put them on a weather map, that's what we would call a synoptic weather map. And so they're put together by our local National Weather Service, in addition to probably other folks. But they, like I said, they kind of take all of those current conditions and take a kind of a bird's eye look at them. And they help meteorologists to anticipate what the weather conditions are going to be in the future, i.e. they help them come up with a forecast. So we're talking a lot of synoptic weather maps. In the past, these were all drawn by hand, whereas now, of course, we rely on computers to generate them and to share them and to archive them. So just to kind of get a sense for examples of a couple of synoptic weather maps, here's one. And I was thinking about the word synoptic, and I was thinking, where have I heard that before? In literature, if somebody's read a book and you ask for a synopsis of the book, that's kind of a bird's eye view of the book, and so kind of synoptic maps probably have that in them. So what you're looking at here, this might look familiar. This looks like, to me, current surface weather conditions here. And then this is a type of synoptic map, and I think we've talked about these before. This is an isobaric map. So basically what they're doing are looking at elevations or ice level heights you need to get to, in this case, in order to be at an atmospheric pressure of 500 millibars. So those are isobaric, these are examples of synoptic weather maps put together with all of that initial conditions.